All right, let's take a look at this problem about cough syrup. We want to find a 90% confidence interval for the population variance and then the population standard deviation for this data set. Okay, so let's go ahead and review the formula real quick. Okay, so a confidence interval for the population variance is the lower endpoint is the sample size minus 1 times the sample variance over that chi-square upper critical value, and our population variance would be in between that one, whoops, and then the upper value would be n minus 1 times the sample variance squared over that lower critical value. Okay, so the pieces we're going to need will be the sample size, the sample variance, and those two critical values from the chi-square table. Okay, so you'll notice that in this particular problem, we're not given the summary statistics. We're given the raw data. So we're going to have to find that sample variance using our calculator. Okay, I definitely don't want to do that computation by hand. Okay, so before I started, I went ahead and put that data set into the calculator under Stat and then Edit. Okay, so you'll see in my first list I have all of those values. Okay, so what I'm going to do is I'm going to go back to Stat, right arrow to one variable statistics, and select list 1. I need to clear out that frequency list because I'm not finding a weighted mean here. Okay, and then I'm going to press calculate. And here, right here, the sigma sub x, this is the population standard deviation. Okay, so in other words, oops, sorry, we want the sample. Okay, let me backtrack for 1 second. We're not treating this as the population data set, so I'm trying to estimate that with an interval. So what I want is the sample standard deviation. Okay, so I'm going to take this value, S, okay, and let me carry it out a few decimal places so that I get a good approximation for the sample variance. Okay, so this is the sample standard deviation. The formula by hand requires the sample variance. So I want to take that value and square it. Okay, so here's the sample variance. Okay, it's about 0.0010325. Okay, I'm carrying that out pretty far so that my answers will be close, if not exact, to the answers in my stat lab, for example. Okay, so now all I need to do is find these two critical values. Okay, so the problem is asking for a 90% confidence interval. Okay, so we're going to need to find those two critical values. So I want to draw a skewed right distribution. Okay, and partition it so that I have two tails with 0.9 amount of area in between our two critical values. So here's the lower one, here's the upper one. Okay, so you definitely don't want to draw a bell-shaped distribution, and remember that you just can't find one of these and then take the opposite, because this is not a symmetric distribution. And the chi-square distribution represents the sampling distributions for variance, and variance is never negative. So this distribution will only take on non-negative values. Okay, Okay, so it's one of the more common mistakes I see is that people go to the standard normal table to get a critical value and take the opposite. Okay, that's going to mess up your whole confidence interval. Okay, so we want to make sure we're going to the right table. And remember, the chi-square table reads from your critical value to positive infinity. Okay, so what I want to do is partition these two tails so that I have an equal amount of area. So there'd be 0.05 area in this upper tail and 0.05 area in this lower tail. Okay, so our table reads this way. So I can go ahead and go directly to the chi-square table, if I can find it. And now remember, if our sample size, what was that, 15? If n is 15, then our degrees of freedom will be equal to 14, okay, n minus 1. So I want to get this upper critical value, I want to read down to 14 degrees of freedom and 0.05 area to the right. Okay, so 14 degrees of freedom, 0.05. It's kind of hard to read. Okay, I get a value of 23.685. Now to get this lower critical value, I have to remember that I'm reading from the critical value all the way to positive infinity. So I have 0.9 amount of area up to here, but then I'm going to have 0.05 more. So to use the table, I have to read over to the column that corresponds to 0.95. Okay, so 14 degrees of freedom, 0.95 amount of area to the right of that lower critical value. I get a value of 6.571. All right, so now I have all the pieces to plug and check. Okay, so just using this formula right here, I'm going to go 15 minus 1 times our sample variance of 0.0010325 over this upper critical value. Okay, so that's going to give me, bear with me for just a second as I get this in my calculator, hopefully not making a mistake. 23.685. Okay, so I get, looking at this, I get a really small value. Okay, I get about 6.1 times 10 to the negative 4. Okay, so it's a value very close to 0. Okay, so that's going to be my lower endpoint. That's going to be for the variance. Okay, so that's about 6.1 times 10 to the negative 4, very close to 0. Okay, so in other words, my lower endpoint is going to have 4 zeros, and then the 610, and so on. Okay. All right, now I need to get this upper endpoint of the confidence interval, so I'm going to find this piece right here, and that's going to be 15 minus 1 times the sample variance over this lower critical value. Okay, so again, putting that in my calculator, hopefully not making a typo. All right, I get about 0.00219998. Okay, I'm carrying it out really far. I know for this section it's a good idea to carry out your values as far as you can. In my next video I'll go over how to get this directly in StatCrunch, which is really helpful. Okay, so this is the upper endpoint of that confidence interval. Squeeze it in there. Okay, so here's our 90% confidence interval for sigma squared. Okay, so this is my CI, my 90% CI for sigma squared. Okay, but the question asked for both. Okay, it asked for the confidence interval for the variance and also for the confidence interval for standard deviation. Okay, so hopefully you recall that the relationship between the standard deviation and the variance is that the standard deviation is just the square root of the variance. So all I have to do is take the square root of these endpoints. Okay, so taking the square root of this left side, and get that in the calculator. Oops, sorry. I'm not having a good time with technology today. Okay, so I get taking the square root of this, and again I've rounded here. So this standard deviation endpoint might be a smidge off. Okay, so I have 0.0247 for my lower endpoint. And then for my upper endpoint, I want to take the square root of the 0.00219998. Okay, up to about, and I'll round to 3 decimal places, 0.047. Okay. So here are my 2 endpoints for my confidence interval. Okay, this is a 90% confidence interval for sigma. Okay, so I get one for variance, one for standard deviation. Now, unfortunately, this is not a built-in confidence interval in the calculator. So if you don't want to use StatCrunch, you're going to have to work through the problems by hand. This one was a little bit longer because I have the raw data set. Okay? So I wasn't given the sample variance right off the bat. But some of your problems you'll be given the summary statistics. Okay, you'll be given the sample standard deviation or the sample variance. Okay, so you can just jump right to the formula. Okay, so just keep in mind this is not a built-in confidence interval in the calculator, but we can put this into StatCrunch and jump directly to the confidence interval for the variance, which is what I'll do in my next video.